right? In this video, we're going to discuss about the concept of angle between two planes, right? Let's say you have two planes, of course. Let's say you have two planes, right, of different normal vector. Okay, means that let's say this is your plane, right? Of course, from here, let's say they are not parallel plane, so they are not parallel. So once you see, you can see that there is an angle between the two planes, right? Angle between the two planes. So I'm going to draw it here. So let's say if you have a plane, right? You have two planes, right? This is a plane on the bottom, and there is a plane on top, right? On top there is a plane. So these two planes is actually intersecting, right? Intersecting. So while the two planes is intersecting, they make an angle, right? There is a angle between the plane, right? This is the angle of the plane, right? And you know that with this plane, they has a normal, right? This plane has its normal, so means I label this to be normal 1, right? For the first plane on top. So, and for the bottom, you have another normal, right? The normal of the plane. So I label this as N2. So these two planes is actually with some angle, right, between them. So means that one is the normal vector is facing the other side, and this one facing the other side, right? So how to find the angle between the two planes, right? By applying the normal vector, right? According to the concept here is the angle between the two planes is actually the angle between the two normal. I repeat again, the angle between the two planes is actually the angle between the normal vector of n1 and n2, but it won't satisfy us until we're going to prove it, right? We're going to prove it. Why is it the angle between the two planes will be the angle between the two normal, right? So to be convinced, so we try to draw a right angle triangle here. All right, where is this right angle triangle come from? So when our eye is see the view, right? Side view. So when our eye is here, so we side view, so we can see that actually here there is a right angle triangle, right? So I want to prove that the angle between the two planes is the angle between the two normal. So how is it? Very simple. So now there is an angle here, right? There's an angle. This is the plane, right? This is the top plane and the bottom plane, right? So then for the bottom plane you have N2, right? You have N2. So the normal vector is N2. For the top plane you have N1, right? You have N1. So means that if I bringing this, so I draw bigger a bit. So if I bringing this, so let's say this is angle, and I'm bringing the N2 as this is a vector, direction vector, so I can joining. So as N1 is facing this direction, right? It's the normal to this plane, right? It's the normal to this plane. So I'm drawing is the normal to this plane, right? And N2 is the normal to the plane bottom here. So okay, so I'm drawing here. So means that N2 I just joining here. So it will be 90 degree here, right? So if I drawing, can you see that? I can actually extend this, So, and this is your N2, right? So, how to proving that this angle is the angle between the two normal, right? So very simple here. So you have 90 degree here, right? You have 90 degree here. Definitely here you will have 90 minus theta, right? 90 degree minus with theta, right? Because total up has to be 180, right? So I take 180 minus with 90 minus with theta, minus with 90 minus with theta, I get the angle here. This is the right angle triangle, right? Total the angle must be 180. So after I calculate, I getting 90 minus theta, right? So that's why here you have 90 minus theta, and total up this will be 90, right? This will be 90. So it means that this must be a theta, right? This must be a theta, because why? Total up these two must be 90. 90 minus theta plus with theta, I will getting 90, right? As these two sum up must be getting 90 degree, right? Based on the concept of geometry, the opposite angle. If here is these two lines, can you see that? These two lines, I draw, can you see that? Extend. So if this is theta, the opposite angle will also theta. So this is a proof, right? This is a proof. Means that the angle between the two planes is actually the angle between the two normal, right? With this knowledge, I can find the angle between the two planes. Alright, so what is the formula? Since that this is the angle between the two planes, is the angle between the two normal. So as we have learned one formula, which is A dot B equals to magnitude of A, magnitude of B, cosine theta, right? The dot product. So I'm going to replace, because I want to find the angle between the two planes, right? Which is also the angle between the two normal, right? So as long as I find the angle between the two normal, and I know that angle represents the angle between the two planes. So I can replace the A with N1 and the B with N2. So magnitude of N1, magnitude of N2, cos theta, right? So if I rearrange this, I will getting theta to be cos of N1 dot with N2 divided by magnitude of N1 N2. Alright, so this will be the formula of finding the angle between the two planes. Alright, so okay, this will be the derivation of this of angle between the two planes, the formula. So in the next video, I'm going to show you how to find the angle between the two planes by using this concept.